This is Darrell presenting Apple's Develop in Swift Fundamentals curriculum, Unit 1, Lesson 4, Control Flow. You will write code that makes decisions about which lines of code should be executed depending on the results of previously executed code. This is called control flow. In this lesson, you will learn how to use logical operators to check conditions and to use control flow statements such as if else, and switch to choose the code that will be executed as a result. Here's an example of the need for conditional flow. If a user is authenticated, then we want to go to the detail screen. However, if a user is not authenticated, then we want to display an error message and go back to the login screen. Here are the logical operators in Swift. Except for the last one, they are all binary operators, meaning they all operate on two values. The first one will return true if the two items on both sides of the operator are equal. The second one will return true if they are not equal. The third one, if the first one is greater than the second one. For numbers, that's obvious. For strings, that could be based on a string comparison. For example, a string starting with B is greater than a string starting with A. And then we have greater than or equal to, less than or equal to. And then we have the logical operators. These operate on two Boolean values. So if the value on the left is true and the value is the right on true, then the logical AND operator is true. Otherwise, it's false. And then we have the logical OR operator. If the value on the left is true, or if the value on the right is true, then the result is true. The other thing to know about these operators is they do shortcutting. So, for example, if the value on the left-hand side of the logical AND operator is false, then we know the result is going to be false, and we do not need to evaluate the value on the right-hand side. Conversely, if the value on the left-hand side of the OR operator is true, then we know the result will be true, and we do not need to evaluate the value on the right-hand side of the logical OR operator. Finally, we get to the NOT operator, or the opposite operator, which operates only on one value and will reverse it. So it will turn true into false, and it will turn false into true. Here is the if statement. If, and then we have a condition which results in a Boolean value, and if the Boolean value is true, then and only then we execute the code inside these braces. For example, here we set a constant temperature to be 100, and then we test if the temperature is greater than or equal to 100. Well, it is, so temperature greater than or equal to 100 will result in true, and as a result we will print out that the water is boiling. There's also an if-else statement. If the condition is true, then we execute the first set of code. If the condition is not true, then we execute the else clause, where we execute the second set of code. Swift has a type called bool, capital B, O-O-L. That is a Boolean value. It can be true or it can be false. Here, number is of type integer, but when we test whether number is less than 10, this will result in a Boolean value, in this case false, and the compiler will infer that is small number is of type bool. Another example, here we have two integers, and we compare them to see if one is greater than the other. Well, that's going to result in a bool value. So is speeding is of type bool. Is snowing is a variable of type bool, and it has an initial value of false. The not operator will reverse that. So not is snowing will have a value of true, and as a result, this code in the if statement will be executed, and we print out it is not snowing. Here we demonstrate the logical AND operator. We test whether temperature is greater than or equal to 65, and that results in true. And then we test whether the temperature is less than or equal to 75, and that also results in true. And then the logical AND operator, we have true, and then the logical AND operator, and then true, and that results in true. So we will execute the if clause, and we'll print out that the temperature is just right. This also shows how we can chain multiple if-else statements together. So if the first statement, if statement, did not work, then we have else, and then we test another if statement, and if that resulted in false, then we would go on to the final else statement and execute the final set of code. Here we show the logical OR operator. In our case, is plugged in is false, so we have to check the second value. Has battery power is true. As a result, false or true results in true, and we print out you can use your laptop. With Swift, you can switch on any type where you can test for equatability. That includes almost all built-in data types. You can switch on a value and you can test for multiple cases. This can be easier to read than multiple if-else statements, which can look cluttered. Switch statements have to be exhaustive, meaning that you have to have a case for every possible case. One way to do that is to explicitly enumerate every possible case. However, that's not possible for all data types, such as integers or strings. So you can also have a default case where if none of the prior cases match, then you match the default case. If multiple cases match, only the first one will be executed. Some languages will fall through from one case to another if you don't have a break statement. However, that commonly results in programming errors. Swift does not do that. Swift does not fall through by default, so you do not need break statements after each case. Here's an example of a switch statement. Number of wheels is a constant integer with a value of 2, and then we switch on number of wheels. We test whether it matches 0, no. We test whether it matches 1, no. We test whether it matches 2, yes, so we print bicycle. We do not conduct any further tests. This switch statement is also exhaustive because we have a default clause. We can match multiple things in one case. In this case, character is of type string, and then we're switching on our character, and if it's any of the vowel cases, then we print this character as a value. So we have 5 possible cases here separated by commas. And then we have our default case, which makes our switch statement exhaustive. We can switch on ranges. Here's a case where it matches integers ranging from 0 through 9 inclusive. And then the next case matches 10 through 99 inclusive, and so on. A slightly similar syntax is where we have a dot dot and then less than sign, which would mean that it is inclusive on the lower end and exclusive on the upper end. So if we had 0 dot dot less than sign 9, then it would match integers ranging from 0 through 8, but not 9. Here's an example where the if-else logic can be a little bit difficult to read, and rewriting it as a switch statement can make things clearer. So we'd want to have one range going from 65 through 75 inclusive, and then we'd want to have a case which deals with everything below 65, and then we'd want to have a default case which handles everything else. In addition, for integers, you can always state the smallest possible value for an integer by using int.min. That is a static property on the integer type. Here's the solution to our conversion to a switch statement. We switch on the temperature, and then we have a case which deals with the range from the lowest possible integer through 64 inclusive, and then we have a case which deals with 65 through 75 inclusive, and then we have a default case to handle everything greater than 75, and that makes our switch statement exhaustive. A common use case for the if statement is to set a variable or a return value. In this case, we're testing a condition, and if the condition is true, then we're setting one value, and if the condition is false, then we're setting another value. Swift has a special operator for handling that. It's called the ternary operator. It's called that because it's the only operator that deals with 3 values. The first is a Boolean condition, and then if the Boolean condition is true, then after the question mark, we have our true value. And if the condition is false, then we have, after the colon, we have our false value. And then that gets assigned into whichever the true value or the false value is the one that the condition chooses, that gets assigned into our variable. So for example, here we test if A is greater than B, and it is. So we take A's value and put it into largest. If you are following the Apple curriculum, you can complete the control flow playground exercises in the lab. The slide deck was created by Apple. The slide deck is licensed by Apple under the Creative Commons Attribution Non-Commercial Share-alike 4.0 International License.